Hello, good afternoon to all the students. Okay, today we start earlier, 11:15. So we also end earlier lah for 1 hour. So for the student on the line, can be reply for me. You can listen me or not? Can listen or not? Okay. We see the student got reply or not lah. For science 2 and for science 3 student, can you listen me or not? Okay. Wait a while for what? Where to go? Okay, can Ahmad. Okay, Su Hui can. Okay, so today I want to go to the new topic. Okay, still the heat, but this is another subtopic. This one should be the last one for the heat subtopic. That's a gas law. Okay, sejarah cikgu still teaching. Next time, can you tell your sejarah teacher, today the time, what's the time for the sejarah should be finished? So you need to remind your teacher lah. Okay, so we on live for the YouTube. If you late comers, so that means you can refer back lah for this one lesson. So I need to go through because I just only got 1 hour. Okay, so our lesson today is a lesson 4.4. That one should be the last one. Okay, for the chapter 4. Okay, I just go through to the Boyle's law. Okay, because this one with the main topic we call it as a gas law. Okay, related about the gas. So we got 3 law involved for this one topic. We got Boyle's law, we got Child's law, and pressure law. So we go one by one. So we go to the Boyle's law first. Okay, now we go to see what's the Boyle's law related. Okay, this one gas law related with the 3 physical quantity we need to teaching. First one is the pressure. Okay, we're talking about the gas pressure. Number 2 is the temperature of the gas. Number 3 is the volume of the gas. So these 3 physical quantity we will each other to be do the relationship. Okay, now we go to the first part. There's a Boyle's law. Okay, Boyle's law, we see which one physical quantity we need to use. Okay, let's see the first one, introduction. Okay, you can see the diagram, a balloon. If you're using the finger, go to press the balloon. I don't call you to press so hard lah. It just spoil. So you just press a bit. So you find it, you compress a balloon with your finger. Why the balloon that does not flatted? Okay, only finger, don't using your hand. Okay, finger, you go to press it. So you find it, they will repulse back, is it, after you release. So this one is why that does not flatted. So this one's one of the question is related with the gas inside the balloon. There's a gas. After that, they got volume. Okay, they got volume of the gases in the balloon. Number 2, when you press it, okay, we apply the pressure on the balloon. Okay, so we see what happened for the volume of the balloon. So now from here, when you just compress, the A inside, they will give the resistance. Resistance means they want to push back. Okay, you press it, they want to push back. The A will push you go outside. So from here, this one observation can be explained by the terms of the behavior of the gas. Okay, you want to compress it, then you got one of the force they want to push back, is it? So this one is related with the gas molecule. Okay, gas molecule. So from here, we need to explain about kinetic theory of the gas. So how the movement of the gas, that means we need to explain from here. Okay, so from here, let's see some example. Okay, this one is example for deliver lah. Nowadays, so many people, they order by Lazada, by order by the Shopee. When they just deliver, example, the goods, you go to order just like the glass one. Okay, you order the juice, you go order the bottle. Glass bottle, normally they cover with the A cushion. Okay, they want to prevent to fall down. Okay, sometimes you need to who is this one. Okay, so we just okay, so from here we're going to see the next part, why we need to cover by the A cushion. So this one A cushion, they just want to prevent the goods in the inside the plastic, they will fall down. When it just fall down, that means they will broken. So from here, this one cushion, they just like the one of the cover lah, prevent the object to be break it. Okay, now we go through to the uh Okay, we go to see this part. Okay, one means of the multitask. Okay, sometimes you need to do the multitask. One means of multitaskity. Okay, so from here we're going to see this part. Okay, behavior of the gas molecule. Okay, we're going to see the just so does not bubble wrap. Okay, yeah, that what we call it bubble wrap. Okay, we call it as a bubble wrap because inside they got A. Okay, so from here we're going to see the behavior of the gas molecule. Okay, behavior of the gas molecule. So just now we want to learn about the kinetic theory, is it? So we see the behavior of the gas molecule first. Okay, first one we need to see about the movement of the gas. Okay, movement, you know like the gas is sure randomly to move. Okay, so uh um Siti No Shakira, can you tell your teacher? Suppose now the time already is 11:50 is a physics class, not the sejarah class. Can you tell your teacher or not? Because maybe your teacher is a new teacher. Is it new teacher? So you inform the teacher today. We dismiss is 1:20 because you got koku. So the time already changed. So you must call your teacher to refer back the timetable. Okay, so from here we're going to see this one, the movement of the A. Okay, movement of the gas molecule. Number two, you see the space. Okay, the space filled by the gas. Okay, we see the spaces between the gas. Okay, after that we see the direction of the motion. Okay, direction of the motion, where the molecule they want to go. Okay, then after that we see the D, collision. Okay, collision of the gas molecule. Okay, they not only collision each other, they also collision with the wall container. Okay, this one is a container. So after that they will hit to the wall of the container. So that means this one is a one of the characteristic you can see about the gas molecule, how they go to move in the one container. Gas that don't have any certain volume, the volume they must depends of the container. Okay, now we're going to see this diagram. Okay, here diagram they can show you the temperature, pressure, and volume. So that means these three physical quantity they will affect the movement of the molecule. So now we're going to see the basic. We're going to find what happened for the gas molecule to move first, how they go to move. We're going to show. Okay, first one you can see randomly to move. Okay, number two, the space. How about the space? The space far away. Okay, molecule and molecule, the spaces is far away. Okay, after that, you're going to see the direction. There are no direction. They simply go to move only. Okay, when I just hit, then they start to move. Okay, so this one is no direction. Okay, D, collision between the gas. Okay, they memang got collision. They got hit each other. They also hit the wall of the container. So this one is all about the characteristic of the gas molecule. Okay, so we go through to the next part. Okay, next part we need to go through to the more specific. Okay, we related with the pressure, volume, and also the temperature. So let's see the first one, the effect of increasing and decreasing. Okay, what happened for the molecule? Okay, we see it, there's a faster or slow. Okay, we see the behavior when we go to adjust the pressure. The pressure of the gas on the behavior of the gas molecule. Okay, now we go and see the observe the diagram first. Okay, here you can see temperature. Now I make the temperature constant. Okay, I never hit it. So from here, the volume I also fix. I don't adjust the piston. So that means the container, the bigger size like this. So I go to adjust the pressure. Okay, I go to adjust the pressure. So from here, you can observe. Okay, so I go to pump. When I go pump, you can see the pressure increasing. 7 atmosphere. Okay, go I keep to pump so you can find it that you keep to moving faster. Okay, the pressure already increased. That means I pump more gas, is it? You pump the bicycle, the tire pump also like this. When you just pump, that means all gas, more gas will go in and go in. After that, they become bigger. But this one, the size we just fix. Okay, I never increase the volume. So that means you find it, the container is the same size. When I just let more gas to go in, you can find it. Okay, more gas to go in, that means collision will be increased lah. When starting less only, collision less. Okay, when I just increase, that means they will hit each other more frequently, and also they will hit the wall container more frequently. Okay, this one is when we go to increase the pressure. So we repeat again to see the diagram, the video clip. When I just press, okay, you can see the molecule increasing. So I keep increasing, go to increase the gas go in. So the molecule also more. Okay, collision will become more frequently. So I increase some more, so they will more frequently go to hit each other. Okay, so this one is what happened when the pressure keep increasing. Okay, now we go and see the explanations. Okay, the explanation is first one, the gas molecule always move random. So I don't care you high pressure or low pressure, they sure will randomly to move. Okay, number two, when the gas molecule, they just collide with the wall of the container and also repulse. When they just hit, they will repulse back. So that means when it just hit the container, actually they exert the force. Okay, because molecule, they also got mass, is it? Got mass, sure got weight. Okay, got weight means you got force lah. So the force will exert on the wall of the container. Okay, wall of the container actually is what? There's a surface area, is it? So that means force acting to surface area, actually you create pressure. Okay, this is one of the formula for the pressure. I think you learned from the first topic, there's a physical quantities. P, pressure equal force over area. Okay, force over area. So that means now it's a force from the molecule, gas molecule, they got weight. After that, they hit to the surface area. Okay, after that, they produce gas pressure. So from here, we can say force per unit area, that is the pressure of the gas. Okay, so that means when I just increase more gas to go in, they more frequently to collide with the wall container. So like this means what? Means now the container is a high gas pressure. Okay, so we go through to the next physical quantities. Okay, there's a temperature. Okay, temperature of the gas, they will affect the behavior of the gas molecule. Okay, so from here, I fix the container. The volume, I never changes, but I go to heat it. Okay, when I just go to heat it, understood, pressure increase. Agree or not? Okay, although I never let more molecule to come in, but when I just increase, understood the pressure inside the container, sure will increase one. Okay, just like one of the container, you go to burn it. Inside very hot, the pressure also must be high. Okay, just like you cook. Okay, you cook, you boil the water. When you keep increasing to boil the water now is in the high pressure. Okay, so now we go to demo. Okay, you observe the temperature. When starting very slow one. Okay, I go to heat 100 and increasing 210 Kelvin. So you see the pressure, they will increase one. But the quantity is the same. Quantity of the molecule is the same. So I keep to heat it. Okay, I keep to heat it, become 405 Kelvin. So you see the pressure already increased. Then the movement also increase. So when temperature increase, we need to talking about kinetic energy. Kinetic energy that will increasing as the temperature increase. Okay, now the volume is constant. So from here, how we go to explain? Okay, the explanation is average kinetic energy of the gas molecule increases with the temperature. Okay, overall the kinetic energy that will increase when you just hit it. Okay, I think this one student will be understand that just like the common sense. Okay, when you just hit it, temperature become high. After that, the movement sure increase. Okay, movement sure increase, collision also increase. So is it when the collision increase means they also hit container. Understood? Also got gas pressure. Okay, so this one is temperature affected the behavior of the gas molecule. Okay, then we go to the third part, volume of the gas. volume of the gas there so also will be affected, okay, the behavior of the gas molecule. That's the volume. You see what happened for the volume. Okay, let's see here. Okay, you can see when I just move the volume go down and down. Okay, you see what happened. Okay, the molecule is the same, quantity is the same, but they keep moving faster and faster. You cannot see they faster. They're not faster because they just no spaces. When they just no spaces, you find it, they will move for the volume become less. So what happened? They keep collision each other. Okay, they will collision each other more frequently because your spaces not enough, ma. So example, just like one of the room. Okay, I let 50 students go in. Okay, so you are easy to move. Maybe the room is a big lah. So if I make half room, then 50 students also go in. What happened? You also will be meet your friends more frequently. Okay, you meet Achong. Then the second round you also meet Achong. Then third round you also meet Achong. Why? Because the spaces become less. So I still keep 50 students go in quarter of the classroom. What happened? No space already. What to do? You need to hit each other lor. Every time you're going to meet your same friends. So this one is a different. Why the volume decreases, the collision will be increased. Okay, you cannot say kinetic energy because now no heating. You cannot say kinetic energy. You just say the pressure should increase. Why? Because you heat the container more frequently because the space becomes smaller. When the space just becomes smaller, you hit the container so many times. So what happened? Pressure increase. So you can see the diagram when the volume just decreases until like this. You can see the pressure increase already, 11.3 atmosphere. But the temperature constant. So I repeat to let you to see. I keep compressed. Okay, compress make the volume become less. So you can see the pressure they will increase because the collisions with the wall container increase. Temperature constant. Okay, they keep moving. Okay, they never faster. They don't have any faster. They just hit each other more frequently. Okay, so from here we do the explanation for this part. Okay, the explanation like this. Gas molecule they move freely. Gas molecules still freely, and also fill in the entire space of the container. Okay, if your container bigger, then the whole container, the gas is inside. If you make the container become smaller, that means inside also is a gas, is it? So that means we depends the volume, let the gas to be moving. So from here, we can conclude volume of the gas actually the same as the volume of the container. So that means the gas they don't have certain volume. Okay, the volume they must depends from the container volume. Okay, so this one is a behavior of the gas molecule. Okay, we're just talking about pressure, temperature, and volume. Okay, now today we want to go through is a Boyle's law, is it? So Boyle's law, we just from the three physical quantities, we choose two out. Okay, because we want to do the relationship, only can do two physical quantity. We cannot do the three physical quantity together. Okay, so from here, let's see, we go to the first one, the Boyle's law, relationship between the pressure and also volume of the gas. Okay, where the temperature? Temperature constant. Okay, we don't touch about the temperature. We're just talking about volume and also pressure. So this one, you can see one of the example, the exercise ball being compressed, okay, when someone just sit on it. So that means when you just sit on it, actually you make the volume become less. You compress, then the volume becomes smaller. So what happened to the air pressure inside the ball? Okay, so that means you go to control the volume, you go to make it become smaller. So now pressure should be responding variable. Okay, then we go through to the next. This one is a one of the experiment. That means you need to write in the report. So I repeat again, For science 2 and for science 3 student, you need to copy this experiment. There's a 4.4. Okay, the first experiment, there's a Boyle's law. Okay, copy inside your exercise book. Okay, later I will show you what's the result. Then what you need to do after copy, you need to plot graph. Okay, that one is the first exercise you need to do for today's lesson. So first one is the inference. Volume of the gas that influence the pressure of the gas. So that means just now the diagram, I go to make the volume become smaller. So we see what happened for the gas pressure. So the hypothesis is the smaller the volume of the gas. So that means the ball, I squeeze, I make the ball become smaller volume. So they say the gas pressure inside the ball, they will increase it. Okay, just like the just now diagram. Oh, experiment book. Sorry, not exercise book. Experiment book. Okay, because this one is an experiment. Okay, so from here, the smaller the gas, just like the just now container I show you, when I just compress, I compress until smaller means the volume become less, is it? What happened for the pressure? Pressure increase. Okay, pressure will be increased. So from here, we need to determine the relationship between the volume and also pressure. Okay, you help me to add the behind sentence important. What should be constant? The mass. You cannot go to add the gas go in already. So we say the mass is a fix. Number two, constant temperature. So from here, these two things already is constant. You cannot go to adjust. So what you can adjust, there's a volume. You control the volume. Responding variable is a pressure. So that means after you go to adjust the volume, you see what happened for the pressure. Constant, so from here you can put temperature. You also can put mass of the A. Okay, let's see apparatus using the syringe. Okay, the injection, the syringe, 100 ml. Then they're using the rubber tube, pressure gauge. After that, rheostat. Okay, let's see the diagram. Okay, diagram you need to draw. Okay, you need to draw your diagram. So from here, we got rheostat. We're using the piston. This one is together, the 100 ml syringe. So that means when you just pull the piston up, actually, they already got A, is it? The A inside the syringe. So this one is a tube, rubber tube you join with the pressure gauge. Pressure gauge, they want to measure the pressure is how many. So that means when you just compress the piston, later the pressure gauge, the pointer, they will move. Okay, the pointer will show what is the reading. So you just read only. So the diagram exactly like this. This one is a Boyle's law demonstrator. When you just compress, that means the tube, they will send about the A. So the A will go into the pressure gauge, then the needle, they will move it. So from here, let's see the procedure. Okay, procedure you can copy from the textbook, but I want you to convert, become passive voice, passive form. Okay, passive form, don't using the active one. So from here, you can see the volume of the A in the syringe. There's an adjusted 100 ml. So when starting 100 ml, so that means you just pull the piston until maximum height. There's 100 ml. So the end of the syringe is connected to the pressure gauge. So you join a tube to the pressure gauge. Initial reading of the volume and pressure of the A in the syringe is recorded. So when starting, the pressure is how many? You just recorded. So the piston now, you start to push. Okay, push slowly until the volume become 90 ml. Just like this, you can see this one diagram. They push in. Okay, when you just push in, you make it until 90, then you stop. Because you see the syringe, they got label, is it? You move until 90, then you stop, then you read. Okay, read the reading from the pressure gauge. So step 3, you just repeated. Now you make the volume become decreases and decreases. Just now 90, then you make it 80, 70, 60, and 50. At least 4 repeated. Okay? So if 4 repeated, that means overall got 5 lah, because 90, 80, 70, 60, 50 is it? So you got 5 readings. So after that, all the pressure P is recorded in table form. Okay, so this one is a procedure. Okay, after that, table form, that means we got result. Okay, let's see the result. Okay, this one's an example result. Okay, so from here, when 100, okay, when 100, they already dropped down. Okay, this one, the last 50, yeah. So from here, we start from the 100. 100, then the pressure also is a 100 kilopascal. Then we find it. Okay, I want you to find the volume is 1 over V. Okay, you find the volume is 1 over V because I just using the 100, 1 over 100, then you pressure now in kilopascal. So from here, second round, I press. The volume become 90. Okay, I read again for the pressure gauge. They become 110. So I continue. I continue to compress, the volume become smaller. So you can see the pressure keep increasing until 165. Okay, so this one over V, actually we need to draw the graph later. Okay, the graph, when you just plot, you can see volume and pressure. Actually, what's the relationship? Okay, the relationship is inversely proportional. Okay, you can see very clear. When the pressure just increasing, the pressure, sorry, if the volume increasing, the pressure is decreased. Okay, excuse me. When the volume just decrease until 60, you can see the pressure increasing until 165. So this one, the relationship is inversely proportional. So from here, we can plot a graph. You help me to plot the graph. The graph now is V is a x-axis. Pressure is a y-axis. Okay, the unit is the same, ml and kilopascal. So later you can get like this. Okay, so this one is a 1 over V. I want you to plot the graph is a 1 over V. Okay, if you plot the graph V and P, you just get inversely proportional. That means the graph is a curve. So I don't want you plot the curve one. I want you to plot the directly proportional graph. Remember, you need to using the standard uniform scale. Okay, 20, 40, 80. Then the bottom one using 0.05 until 0.02. Okay, then you plot. Okay, then you draw. Remember, the line must pass through 0. So this one is a directly proportional graph. Okay, then we go through to the analyzing. Okay, analyzing. So this one is P versus V. So that's why I don't want you draw. Okay, I don't want you draw the curve one. Pressure and volume, the relationship is inversely proportional. Okay, if I just convert, the volume become 1 over V, so they will become like this, directly proportional. Okay, so from here, we don't have any symbol for inversely proportional. We just got symbol for directly proportional. They're just like the alpha, is it? So from here, normally for the physics, they want you to plot the graph. Normally, the graph should be directly proportional. Because inversely proportional, there's a one of the graph, no need using the pen, no need using the ruler. There's a one freehand to draw. So maybe when freehand to draw, you will draw out of the point. So what we need to do, normally we want to convert, become 1 over V. Okay, become 1 over V. So from here, we go to the next part. Okay, now it's a Boyle's law. Okay, experiment finished. So we need to explain the actual relationship, the volume, and also the pressure. Just now experiment we prove already, inversely proportional. So from here, we need to explain again the definitions. Okay, definition for the Boyle's law, there's a pressure inversely proportional to the volume. Okay, pressure inversely proportional to the volume. Then you need to mention the mass must be fixed and also the constant temperature. Okay, so Boyle's law, we still need to explain by kinetic theory of the gases. Okay, we still need to explain. So how to explain? We explain about the volume because we control the volume. So from here, you can see first part, when the volume of the gas decreases, you compress, the volume decreases. So you must mention because your mass is the same. So now same number of the molecule, they move in a smaller space. Is it? Then what happened? So you see the number of the molecule per unit volume increase. So that means the space of the volume, they will hit the part always increase. So the number of the molecule is a fix, but now the volume decreases. So that means when you hit the part, they will keep increase. You no space to go, man. You only got this one space. So the molecule per unit volume increase. So that means not only hitting, they will make it fast. But this one situation, you cannot talking about fast. No kinetic energy increase. Only you can mention molecule per unit volume increase. Then you need to say about collision between the wall container. Okay, molecule and molecule, when they just hit, no gas pressure, only molecule hit wall container, they got gas pressure. Okay, remember, molecule and molecule hit, there's a elastic collision. Elastic collision cannot create gas pressure because you already positive hit, negative, no more already. But container cannot move. When you just hit the container, that means you create gas pressure. And the last one, force per unit area on the wall of the container also increase because you hit the wall more frequently. Finally, you create increased gas pressure. Okay, so this one is how we go to explain kinetic theory by using Boyle's law. Okay, don't touch about temperature. We just say the volume, you make it smaller. Then you say about the number of molecule per unit volume increase. So that means collision between the molecule and wall container increase. So force per unit area increase means the pressure also increase. Okay, so this one we call it as a Boyle's law. You can see the diagram. Okay, this one is a piston. When I just compress the piston, you can see the volume become less, become half. Okay, how about the pressure? Pressure will be increased. Okay, then we go through to the equation. Boyle's law, P directly proportional 1 over V. Is it? Okay, so that means if I just ignore the directly proportional, I create one of the K. Okay, P equal, I put equal, K bracket 1 over V. What means of the K? K actually is a gradient. Okay, gradient, when you plot the graph, P versus 1 over V, there's a original pass-through origin, is it? Directly proportional. So that means you find the gradient, actually there's a K. So from here, K, we just call it, there's a one constant number. Okay, constant number. So you can see the graph. This one is an example graph. If I plot one straight line, so I take any point on the line, I find the gradient is almost the same. Okay, almost the same. So I take first case. First case is a P1 and 1 over V1. This one is a case 1. Okay, case number 2, we also plot. So you can find it, the point on the same line, when you find the gradient, there's the same answer. Okay, so this one, we call it as a K, as a gradient. So I can create the equation now. Condition 1 of the gas, there's a P1, V1 equal K. Is it? Okay, number 2 is a condition number 2. Gas, also same gas, is it? So we create P2, V2. Okay, there also is a K. So that means maybe the first round you make the volume become smaller. Second round make it become bigger. So that means when you just plot the graph, you also get the gradient should be the same. Okay, both also is a K. So finally, I can create the equation for the Boyle's law. Extra one of the S, Boyle apostrophe S, no double S. So from here should be P1 V1 equal P2 V2 because both also is a gradient. So this one is a one of the formula for Boyle's law. Okay, no temperature. So from here, P stands for pressure of the gas, V stands for volume of the gas. So the temperature must constant. Okay, So this one is the first formula for Boyle's law. P1, V1. So you can see P and V actually is inversely proportional. When I increase the P, V must be dropped. Okay, because they're side by the side. Okay, so this one's one of the tips to let you to see. This one is a full piston. The piston, the volume is bigger. So when I just make the volume become decreases, then you can see the molecule. They will more frequently go to hit the wall container. Okay, but then velocity is the same. No increase the movement, just collision increase. So this one is one of the smart info to let you to remember the formula. You see the triangle. The triangle is set by the PVT. P is pressure, V is volume, T is a temperature. So for the Boyle's law, which one constant? Temperature constant is it. So you go to close the temperature. When you just close the temperature, you can see P and V. Okay, side by the side, P and V. So we can create the formula PV equal constant. So the formula is a P1 V1 equal P2 V2. Okay, so this one is a formula for the Boyle's law. Okay, so finish for the Boyle's law formula. We need to try some of the exercise. If not, we don't understand, we can do or cannot do. Okay, let's see here. Question number 1. Okay, A in the closed range has the volume 60. So we take the range is a first case, 60 cm cube, and the pressure is a 108 kilopascal. So I drop down. V1 is a 60, P1 is a 108 kilopascal. The piston in the stream now you go to push it, you go to compress. To the volume become 48. Now they ask you, what is the pressure now? Okay, prepare your calculator to show me what's the answer for P2. Okay, I show you equation. P1 V1 equal P2 V2. That means the whole question no temperature. So no temperature, that means there only is a Boyle's law lah. They're talking about pressure and also volume only. Okay, so please prepare your calculator. Give me the answer for P2. What is your new pressure now? Okay, when I go to compress the syringe until 48 cm cube. Okay, anybody here can answer it? Okay, Celian gave me 138 kilopascal. Okay, if the P1 is a kilo, so we no need to change. Okay, your answer also follow kilopascal. Okay, if you see the V1, V1 is a cm cube. So that means the second one, they're also using cm cube. Okay, actually the unit you no need to change. Unless both sides the unit is a difference, you need to change. Okay, so we show the calculation. 108 multiply 60 equal P2 multiply 48. Okay, I find the P2 is 108 multiply 60 over 48. So the answer is 135 kilopascal. Okay, we still copy the same unit, kilopascal. Okay, I think this is no problem for yours. Important is you understand the question. Okay, then we go to the second question. Okay, second question, you must think about the this one, the depth of the sea. Okay, depth of the sea. So that means on the surface and on the deep sea, the pressure is a difference. Okay, pressure is a difference. So you can see this one diagram. Now a bubble. Okay, a bubble at the bottom. Okay, the volume is a 4 millimeter cube. Okay, the depth is how many? 5 meter. 5 meter from the surface. Then surface, we got what pressure? Atmospheric pressure. Then the atmospheric pressure is how many? 10 meter water. Okay, so that means if at the deep sea, how many pressure? You need to add lah. 10 meter water plus 5 meter. So total pressure acting to the ball now is a 15 meter water. Okay, from here we never count about Pascal. We just using the unit is a meter water. Okay, you can using the unit for the pressure for calculation the water. So we just say 10 meter water or you say 15 meter water. That one is a unit for pressure now. Okay, so from here we see the diagram, see the question. A bubble at the bottom has volume 4 millimeter cube. So the A bubble is at a depth 5 meter from the surface. So assume there's no changes in the temperature. So the temperature constant. Find the volume of the bubble when it rises to the surface of the pool. So that means until this one bubble, they rises until to the surface. They ask you, what is the volume? So when it rises to the surface, now you need to change the pressure. The pressure will change atmospheric pressure. Is it? So we go to show about the info. Okay, info V1 is a 4. Okay, V2. V2 we do know. Okay, V2 is when it just rises up until surface. Okay, P1 is how many? P1 that's from the surface, the atmospheric pressure. You need to plus the water pressure. Okay, so from here, I think this one a little bit corrections. Not atmosphere. This one is atmosphere plus water. Okay, I got to change. This one is the pressure of the water and also pressure of the atmosphere. Okay, so there's a two things. So pressure of the water plus pressure of the atmosphere when there's a P1, when they're in the deep sea. So P2 means when they just move until to the surface, they only got atmosphere. Okay, so V2 we do know lah. So the formula is the same. P1 V1 equal P2 V2. So you need to tell me what is the V2 now. Okay, what is the V2 now? Okay, so from here, let you to do the calculation for the second question. Okay, this one question we no need using Pascal. Okay, we straightforward using the unit for meter water. Okay, I already give you the P1 is how many? Okay, P2 already is here. So you calculate for me what is the V2. Okay, what is the V2? Okay, you show for me what is the V2. Okay, can do calculation or not? I think this one just a simple question. Okay, Celia give me 6 millimeter cube. So we go to show. Okay, first one, P1 is a 10 plus 5, because 10 meter plus 5 meter. Okay, multiply with the 4. 4 is a volume. Millimeter, that means we no need to change. We're still using millimeter. So after that, equal to P2. P2 is on the surface. On the surface, how many? 10 meter water. Then V2, we do know. So final answer, we need to find there's a V2. So the answer is a 6 millimeter cube. Okay, correct. So that means you can find it. The ball, the A bubble ball, when it just go to the surface, the size become bigger. 4 becomes 6. So this one you can observe. From the aquarium, you can observe the A bubble from the fish at the bottom until go to the surface. You can find the A bubble become smaller, smaller, become bigger until to the surface. Why? Because the volume increases, pressure decrease. Okay, pressure at the surface is less than the pressure at the bottom. So that means volume and pressure inversely proportional. When the pressure become less, the bubble will become bigger size. So that means always the bubble, when it just flow until to the surface, the bubble should be the biggest one. Okay, so from here we need to go is number 3. Okay, number 3. Now the photograph they show about the syringe, okay, with the nozzle closed. A in the syringe has an initial volume. Okay, they give you initial volume 7.5. So we take this one as a V1. Then the pressure is 105 kilopascal. Now the A is compressed. Now they go to compress. But they just go to compress and make it become 2.5. Okay, they make it become 2.5. So what is the pressure of the A? Okay, now when 2.5, what is the pressure? So from here, we need to go and see the info. Okay, 7.5 cm cube, V1, P1, then V2, 2.5, 2 to know. Okay, we're still using the same formula. Find for me what is the P2. Okay, what is the P2? Okay, still same calculations. Okay, 315 kilopascal. So my class only got Xiliang, is it? The rest do not go where? I got 52 watching, but only Xiliang to answer me. Okay, so the calculation 105 multiply 7.5, then equal P2 multiply 2.5. Finally, I want to find is a P2. So the answer is 315 kilopascal. Okay, so this one is a Boyle's law, just a simple question. Important you understand this one is what law, because now I just teach about Boyle's law, so you know lah, because later we need to combine. We got Boyle's law, Charles' law, and pressure law. When the question just come out, then you need to understand. Now the question is Boyle's, Charles, or pressures. Okay, so we go to number 4. Okay, number 4 got a little bit harder. Okay, let's see number 4. A figure A, okay, figure A, they show about the capillary tube, with the trapped mercury. Inside got one mercury at the middle. The mercury length is 2 cm. Okay, now the length of the A is bottom one. Okay, bottom they trap the A. In the tube, there's a 10 cm. Okay, for the first one. Now second one, they take the same capillary tube, they go to inverted terbalik. Find the length of the trap A if the tube is inverted, shown in the figure B. Now you can see terbalik. When it just terbalik, you cannot say this one become 10 cm already. They will change. So they say this one is a H lah. They don't know how many. But the mercury is the same. Mercury is still 2 cm. Okay, now they give you atmospheric pressure. So you must think about atmospheric pressure, whatever. You are terbalik, you are lying, you are sitting, you are sleeping. They also got atmospheric pressure. Because atmospheric pressure is acting to anyway. So from here, if I say figure A, okay, figure A, you can see atmospheric pressure acting inwards. Okay, atmospheric acting inwards. I show you the atmospheric first. So the atmospheric is acting to the capillary tube. So if I terbalik, they also got atmospheric pressure acting to the capillary tube. Okay, the difference is the mercury. You see the mercury weight. Okay, first mercury weight is acting downwards. Mercury is always acting downwards, man, because our weight is go downwards, is it? So from here, the first one figure, you can see the mercury, they're acting to the A. Okay, 2 cm mercury acting to the A. Atmospheric pressure also acting to the A, is it? This one 10 cm is a A. Now I inverted. If I terbalik, so you see the mercury. Now the mercury never acting to the A already. They're acting opposite direction. They go to the atmospheric already. So the atmospheric, they're still acting to the A. Okay, I don't care what direction. The atmospheric pressure still they're acting to the object. So from here, you can see the movement of the arrow. PO and also mercury, same direction, go down. Second diagram, mercury and also the atmospheric direction, opposite. So that means later you need to minus. Okay, so now I go and show the info. V1. V1 is a volume. So volume, they say they give you 10 cm. 10 cm not volume. 10 cm is a length. So when you want to write correctly, so 10 multiply area, the area of the capillary tube. So there's a 10 cm cube lah. So V2 we do know. V2 there's a H. So H multiply area. That one is a V2. Okay, PO. PO is the atmospheric pressure, 76 cm mercury. They're using the cm mercury. You see the pressure got so many different unit. Just now it's a meter of water. Now it's a cm mercury. So different unit. So P1 is how many pressure? P1 we see the figure 1. P1 means how many pressure acting to the A? We got 2 pressure acting. One is an atmospheric, another one is a mercury pressure. So from here we the 76 plus 2 cm. So becomes 78 cm mercury. Okay, understand? So how about the second figure? Second figure, you are terbalik. Okay, if you are terbalik, atmospheric pressure still acting in, still masuk. The problem is your mercury now is terbalik. Your mercury now is acting another opposite directions. They go downward also, but because you are inverted. So that means your mercury crash each other. So you need to minus. Okay, so the atmospheric pressure now 76, you need to minus 2 cm because the direction is opposite. Okay, normally we take the big one minus the small one. So now your second pressure is how many? 74 only. Okay, 74. So from here, I need to calculate. What I need to calculate? I want to calculate the H. Okay, I want to calculate H. So what we need to do, we calculate the V2 first. Okay, we calculate the V2. So the formula is the same. Okay, I show you. P1 is a PO plus 2 cm mercury. So P1 become 78. So P2 is an atmospheric minus. So you will get the answer from the info here. One is 78, one is 74. So we're using same formula. So give me the answer for H. Okay, I want the answer for H. Because the A later we can cancel each other. Then I show you. Okay, you can see the HA. HA actually is a V2 lah. I put here. 78. 78 is a this one P1. P1 multiply V1. V1 how many? 10A. So over P2. P2 is 74. Okay, so the A actually we can cancel each other. Finally, you only find the H only. Okay, so now you tell me what is the H. Okay, I want the answer for the H. Okay, so this one is an explanation for question number 4. Okay, a little bit more compared to the shortest one. This one is a little bit thing you need to understand. How about the tube? Okay, create the pressure. Okay, remember, not only for pressure, we got atmospheric pressure. Okay, answer from Silang 10.54 cm. Okay, we go to check. Okay, so the A we just cancel. So the final answer 10.54 cm. Okay, so this one is an example for the exercise. Okay, I already upload in the Google Classroom. Okay, finish already actually. Okay, this one is a today task. I already upload in the Google Classroom. They got some of the exercise, 3 questions only, but the last question is related with just now what I teach you about the capillary tube. So that means you need to do it. The due date is Friday. I set already for Friday, 5 p.m. You need to pass up, turn in. Don't pass up to me. You turn in the Google Classroom. Okay, don't PM me in Telegram. Turn in the Google Classroom for this exercise. Can you see a label? There's a PBD. That one is the marks for yours. Okay, the PBD marks. So remember to do it and also pass up. Don't until the due date. Okay, due date, I repeat again, there's a Friday, 5 p.m. So better you do first lah. After do, you turn in. Okay, so another one is a Google form. Google form I already upload. So some of the question about the Boyle's law, you need to do it. Okay, don't have. So later I check for you. Later I check for you. So Google form go or not? You can see the Google form or not, Celia? Okay, Google form. You check Google form first. Inside the GC don't have the question. Okay, later I go to check. Google form I already go or not? You check Google form go or not? I already sent in the Telegram. Okay, Google form you got. So that means you do the Google form first. Okay, Google form is hashtag. Got code lah. Today code hashtag volume. VOLUME. Okay, you help me to type there. Hashtag. Okay, you help me to type the hashtag. Find the hashtag. Hashtag volume capital letter. Okay, so that one is the code. Today lesson code. Okay, I already put here. Okay, hashtag volume, capital letter volume. Okay, yeah, I already pin there. So you just type, don't copy and paste. Okay, one more thing, Google Form only can log in by using MO email. Don't using your Gmail. Okay, then the Google Classroom, I go to find out what's the problem. Then I will upload for you again. Okay, so our lesson just until here for the boys law. So thank you for everyone to watching and also give the response for Siliang. Thank you for Siliang. Okay, the rest the student you are miss out, you can repeat to watch again the YouTube lesson. Okay, I already live and also upload there already. Okay, everyone, just thank you and also bye for your lesson. Okay, you can go through, do the Google form. Okay, bye everyone.